Dear students, good morning. Already we discussed the IIT JEE problems, objective type questions in the chapter application of integrations, that is finding the areas bounded between the curves. We solved 8 problems. Now I am going to 9th one. You see on the board 9 and 10 problems are given. You see the 9th one. If A, capital A, is the area of region bounded by the curve y is equal to root 3x plus 4 on x-axis, and the lines is the line. Lines x is equal to minus 1 and x is equal to 4. And again, capital B is the area of another region bounded by the curve y square is equal to 3x plus 4. On x-axis, same lines, x is equal to minus 1, x is equal to 4. Then what is the ratio of the two areas of the two different regions? That is the thing. For appearance, the problem is very large. Two different questions are there. And we have to find the areas, and then we have to find the ratio. But you see, whenever in the objective, the question is large and typical, by seeing the question, the answer will be very sharp. Easily we can solve. You see, here a logic is there, very simple logic. A is related with the curve. With the curve y is equal to root 3x plus 4, where x is equal to minus 1, x is equal to 4, within the ordinates. B is the curve under y square is equal to, the curve y square is equal to 3x plus 4 and x is equal to minus 1, x is equal to 4, Same ordinates, the curve also same. Here y is equal to root. Here also y is equal to root of 3x plus 4. Okay now? So here A and B, the two regions are same. So A is to B is equal to 1 is to 1. Very simple question. Okay now? Because here the curves are same curves. That is the thing. Next, the 10th one. Area bounded by the x-axis and the curve y is equal to f of x with the ordinates, lines, x is equal to 1 and x is equal to b is root of b square plus 1 minus root 2. Then what is f of x? In a regular concept, we are given a function within the given limits, ordinates or lines, we can find out the area. But here the area is given root of b square plus 1. B is a constant, a number, root of b square minus 1 minus root 2. And the function is not defined. Why is f of x simply? And we have to find, it is in the reverse method, we have to find the function. You see, solution. Observe it. You see, within these limits, that is x is equal to 1 to b, f of x dx is nothing but root of b square plus 1 minus root 2. Okay na? Here we are asked to find the f of x. So we differentiate with respect to b, not with x. If limits are not there, we can differentiate with respect to x. But limits are there. 1 b is unknown. So with that unknown value, we are differentiating. So that the integration will be dilated and we get f of x in LHS. Okay, now? Once again, you observe me. The area bounded by the curve y is f of x within the limits is this one. This is the formula. The definite integral with the given limits of the function is the area. This area is already given. So we are differentiating with respect to not x, b. It is integral 1 to b. F of x dx is equal to d by dx of root b square plus 1 minus root 2. Here the differentiation and the integration cancels. We get f of x is equal, f of b. Okay, now f of b is equal to, it is 1 by 2 root of b square plus 1 into 2b. Okay, now root something is 1 by 2 root something. This is 2 root something. 2 root something into for something. B square is 2b plus 1 is 0. Minus this is a constant. So it is 2 cancels. We get f of b is equal to b by root of b square plus 1. That implies, substitute x. We need generally x. F of x is equal to x by root of x square plus 1. Okay, now like that we have to differentiate. By differentiating this to b, we can find the function. So this is a D option. The fourth option. Okay, now that is the thing. Okay. The 11th problem. You see, the ordinates x is equal to a. The only ordinate x is equal to a means it is a vertical line. X is equal to a divides the area of the region bounded by the curve y is equal to 1 plus 8 by x square. It is a curve. This is a curve. On x-axis, within the limits x is equal to 2 and x is equal to 4. That the region is divided by x is equal to a with the line x is equal to a into 2 equal parts. Then what is a? You see, it is x-axis and y-axis. Here it is x is equal to 2 and it is x is equal to 4 assume. These are ordinates. Curve it is not necessary to trace. It is not easy. So simply we assume this is a curve whose equation is y is equal to 1 plus 8 by x square. When x is equal to 2, at the limit x is equal to 2, x is equal to 2 means is a vertical line, ordinate. When x is equal to 2 means y is equal to 1 plus 8 by 2 square is 4, that is 3. So this is 2 comma 3. Say it is a point. And at x is equal to 4, y is equal to 1 plus 8 by 16. It is 1 plus half means 3 by 2. So it is point B 4 comma 3 by 2. So 3 by 2, it is ordinate 3, whereas this is 3 by 2. Okay, now? So curve is like this. Right, okay. And this area bounded by the curve within the limits x is equal to 2 and x is equal to 4 is divided by a line, not at middle. It is divided by a line x is equal to a into 2 parts. One part is like this is one part we assume, and this is another part you assume like this. Okay, na? It is 1, it is 2. These two areas are equal. That is given. Then what is A? A means it is not 3. In between 2 and 4 it is a middle. So that it is divided into two equal parts. That is wrong. It is somewhat. Okay. How can you find, you see, integral 0 to, 2 to 4 total area by the curve 1 plus 8 by x square dx. This is the total region. Okay, A, B, say C, D. A, B, C, D is the area, total area given, that is within the limits 2 to 4 is 2 times. Okay, na? 2 times integral 2 to A. Will you agree? 2 to A. Both are same. A to 4 or 2 to A. Whatever maybe you write. Of the same curve, under the same curve, 1 plus 8 by x square dx. Okay, na? Or otherwise, you write 1 by 2 here. Also, this area is divided by 2. That means it is half of that area is equal to 2 to A or A to 4 also. Okay, na? It is 1 by 2. For 1 is x. Here 1 by x square is 1 by x square integration is minus 1 by x. That is minus 8 by x. Okay, na? It is with the limits 2 to 4. And here it is x minus 8 by x with the limits 2 to A. Okay, na? It is very simple. You substitute to 4 minus again 2. Here substitute to A again 2. Then we will get the answer. A is equal to, it is 2 root 2. It will come. Okay, na? It is a simplification. Easily you can solve it. Okay, na? Substitute upper limit minus lower limit. Here also upper limit minus lower limit. And simplify. 3 or 4 steps will come. At last we get A is equal to root 8. That is root 8 will come to root 2. Okay, na? Right. Here, 12th one. You see, the 12th one, here the curve y is equal to A root x plus bx. Unknown factors A and B is given, which is passing through the point 1, 2. And area by this curve with this ordinates x is equal to 4 and x is equal to on the x-axis only. Only one ordinate is given. X is equal to 4 means another one is 0 to 4. That is the meaning. X-axis is 8. That area of the region by this curve on x-axis with this ordinate is 8 units. This is 8 units. Then what are the values of A and B? So it is 0 to 4. Only we are given the x is equal to 4 means another one is 0 from horizontal side. 0 to 4, it is y dx. Y means A root x plus bx on x-axis. Dx is equal to 8. Okay, na? And one more thing is it is passing through and it is passing through the 1, 2. So y is equal to 2 when x is equal to 1. So 2 is equal to A root 1 plus b into 1. Okay, na? So A plus b is equal to 2. It is there. Okay, na? A plus b is equal to 2 means simply by verification method. 3 minus 1. 3 minus 1 is 2. 3 plus 1 is 4. Not this one. It is minus 3 plus 1. Not also this one. The minus 3 minus 1. Okay, na? By verification. By verification. Very simply it will solve. Not also this one. It is not needed because the options are given like that. You see, where given A plus B is equal to 2 na, You substitute that 1, option 1. It is 3 minus 1 is equal to 2. Yes, it is correct. You substitute the second, third, fourth option will not satisfy. Okay, na? So like this we have to prove. Yeah. Okay, na? Now 13th problem. You see, the curve is y is equal to x e power mod x. Mod x means at x is equal to negative, it is e power minus x. For x negative, positive, it is e power x. And the ordinates, that is limits, lines, are mod x is equal to 1. Y is equal to 0 means it is x-axis. So, we find the area. You see, observe it. Given y is equal to f of x is equal to, it is x e power minus x for it is minus 1 less than x less than 0. Okay, na? When x is negative, it is a minus. And x e power x for 0 less than or equal to x less than 1. Okay, na? That is the meaning. Why you are taking within the interval minus 1 plus 1 means the ordinates are mod x is equal to 1 means it is between minus 1 and plus 1 only. So like this. The curve here it is not needed. It is not needed. Actually it is drawing the diagram is not needed. The area is integral minus 1 to 0. When the limits are minus 1 to 0, it is x e power minus x dx. Plus, when x is equal to 0 to 1, the limits, the curve is x e power x dx. It is very clear. Here, the curve is known, but the diagram is not mentioned. In the theory part, okay. But we know that the curve is, the equation is given, y is equal to something, and we know the limits. Then the area is like this one. It is by Eilert formula. Eilert, first function, second function. X, the integration of e power minus x is e power minus x with minus, by minus 1 is there, it is minus. And minus integral x is 1, the differentiation. For the first function, differentiation and this one. You see, it is e power minus x by minus 1 dx with the limits minus 1 to 0. Here also x e power x minus it is e power x dx with the limits 0 to 1. Here it is minus 1 to 0. It is see, it is minus x e power minus x. It is plus minus by minus. E power minus x is again minus e power minus x with the limits minus 1 to 0. And here it is x e power x minus e power x with the limits 0 to 1. You substitute the values, simply we will get the answer. Okay, now I will do it here. You see, it is when you substitute minus of minus 1 e power 1 and minus e power 1. I substitute, not minus 1, it is 0. Substitute 0 minus e power 0 minus, you substitute minus 1. It is 1 e power 1 minus e power 1. Okay, na? Okay, na? Right. Plus, again substitute 1 e power 1 minus e power 1 minus 0 minus e power 0 is 1. Okay, now it is minus 1, it is 0. Again it is e minus e plus 1. Okay, now it cancels. I think it is minus half minus, it will come plus. So it is 2 answer. Okay, now option 4. Okay, yeah. Now the 14th problem. The area bounded by the lines x is equal to 0 and x is equal to 2. The curve y is equal to 2 power x and y is equal to 2x minus x square. Okay. I will solve here. So see, I will solve here. We are given the curve y is equal to 2 power x and y is equal to 2x minus x square. Okay, this curve is okay. You change this one. With x square minus 2x is equal to minus y now. It is x square minus 2x plus 1 is equal to 1 minus y now. We are adding 1 on both sides. Why? Because in order to make it as a completing square method, it is x minus 1 whole square. X minus 1 whole square, x square minus 2x plus 1 square is 1. It is a minus of y minus 1. So this is x square is equal to 4ay, a parabola. It is a parabola whose vertex is 1 comma 1. And this is symmetric to negative y-axis. Will agree? It is minus is there. X square is there. So it is a minus y-axis. Symmetric to minus y-axis. All these are simply for the knowledge purpose. Okay, but you have to learn it. But here it is y is equal to 2 power x. I will draw the diagram here. You see, it is x-axis. It is x-axis and it is y-axis. It is horizontal. Y is equal to 2 power x. It's a curve like this. Okay, na? It is a curve. When x is equal to 0 here, x is equal to 0, y is equal to 2 power 0 is 1. Y is equal to 1. When x is 0, y is equal to 1. So here it is 0 comma 1. Like this, the curve is if x is equal to 2, y is equal to 4. X is equal to 3, y is equal to 8. Like this it is going on. Okay. And here it is a parabola. It is symmetric to negative y-axis and whose vertex is 1 comma 1. You see, here is 1 comma 1 is a vertex. Okay, now? And you see, when x is equal to 0 in the second curve, x0 means y0. So it is passing through. It is passing through origin at the sharp at 1 comma 1. Okay, now? Okay, then? And you see, this is actually the curve. It is like this. And what we are asked, the area bounded by the lines 0 and 2. You see, where this parabola cuts x-axis means it is perfectly 0 comma 2. Yeah. Y is equal to 0 means, you see, 0 is equal to 2x minus x square. In the second curve, substitute. Where it meets the x-axis means putting y is equal to 0. So x of x minus 2 is equal to 0. X is equal to 0 and x is equal to 2. One is known, this is x is equal to 0 and x is equal to 2. Perfectly it is given. We traced the curve also. Now we need, this is the area. It is going on this one. Whether this is it area? Is it area? Now this is not. This region, you see that? This region, O, say it is some point B. OAB is the region bounded by only the parabola. But we are asked, here two curves are there. So at this point, you take like this, a line, a dotted lines. You write the diagram as a dotted line. Okay, now it is D, C, D, O, B, A, C, D. This is the area. Okay, now it is the area required. This region bounded by this region is bounded by the two curves. We need that one. Okay, now we solve the problem. See, area is integral 0 to 2. The upper curve is 2 power x minus 2x minus x square dx. It is 2 power x by log 2. A power x integration is a power x by log a. Here it is 2 power x by log 2 minus, it is 2x means x square minus plus x square is x cube by 3 with the limits 0 to 2. Now we substitute. First upper limit. It is 2 square is 4 by log 2 minus 2 square is 4 plus 2 cube is 8 by 3. Okay, now minus 0 substitute. It is 2 power 0 is 1 by, it is log 2 minus 0 plus 0. Okay, now so it is 4 by log 2 minus also there. So minus 1. 4 minus 1 by log 2 is same. It is minus, for this one same is minus 12 plus 8. Minus 12 plus 8 means minus 4 by 3. So this is 3 by log 2 minus 4 by 3 square units. Where it is the formula. Okay, now like this we have to solve it. Go through it. Okay, pause. Okay. This is the last problem, 15th problem. You see, I have to find the area of the region which is bounded between the two curves y is equal to sin x and y is equal to cos x in the interval 0, pi. You see, here is graphical knowledge is essential. Graphical knowledge. It is horizon, it is x-axis, and it is y-axis. As you know, the sine curve, you see, it passes through horizon and it is maximum at pi by 2. X is equal to pi by 2. Okay, now at x is equal to pi by 2. And again it bends and reaches at x is equal to pi. Sin 0 is 0. Sin pi by 2 is 1. Okay, now. Whereas again sin pi is 0. So sin curve is like that. Again it bends towards x-axis and goes upward, reaches plus 1. Okay. Whereas the cos curve also it is at cos 0, x is equal to 0, cos 0 is 1. And it meets x-axis at pi by 2. Cos pi by 2 is 0. Cos 0 is 1. Cos pi by 2 is 0. And again, you see, it comes, and again it raises. Like this. But it is not needed. It is okay. It is fine. Okay, now. It is minus 1. It is minus 1. It is plus 1. Okay, now. We have to find the area between the two curves in the limits 0 to pi. You see, this curve is y is equal to sin x, and this curve is y is equal to cos x. Here it is clear. The curve is the cos and the sin both will meet at one point x is equal to pi by 4. Sin pi by 4 is 1 by root 2, cos pi by 4 is also 1 by root 2. So, in between 0 to pi by 4, cos is upper and sin is lower. Okay, now? Like this. Whereas in between pi by 4 to pi, sin is upper and cos is lower. It is a different one. Here is a different one. So like this you have to draw the shade the region with lines, horizontal or vertical also. So there are two types. Not this area. You see, you may get some doubt. What about this area? This area is, you see, this area, it is under sin x only, and this area, it is under cos x only. Okay, now, so it is not the question. Bounded by the two curves. This is the area, and this is the area. Now, required area is integral 0 to pi by 4, 0 to pi by 4. 0 to pi by 4 is one part. So it is one part A1 and it is A2 just like. It is the area A1, A2 like that. It is 0 to pi by 4. Upper curve is cos x minus sin x lower curve. For A2 is it is pi by 4 to pi. Upper curve is sin x and lower curve is cos x. It is for cos is sin integration minus sin x minus of minus plus cos x. Why? Because for sin x minus cos x is integration minus of minus plus. Plus again for sin x is minus cos x minus cos x is sin x with pi by 4 to pi. Okay, now. So it is cos pi by 4 1 by root 2 upper limit plus sin pi by 4 1 by root 2 cos pi by 4 1 by root 2 minus sin 0 is 0 plus cos 0 is 1. And here minus you take it as common and it is cos plus cos is there, cos plus sin. Don't confuse. I am sending this minus. You put a plus 1. Cos pi is minus 1. Sin pi is 0. Minus cos pi by 4 is 1 by root 2. And plus 1 by. So this is root 2 naira. 1 plus 1 by root 2. 2 by root 2 is root 2. Minus 1. Minus 1 plus here also root 2. Root 2 plus root 2. It is 2 root 2. This is minus 1 plus 1 cancels. Okay na? So 2 root 2 square units is the answer. Okay na? 2 root 2. The first option. Okay na? This is the answer. Okay, like this we have to solve. Okay? Thank you.